I want to talk about something really cool. Um, how many of you have heard of cryonics? Awesome. I'm not going to talk about that. Um, I'm going to talk about what we do at CryoDAO, and I make some of these jokes because it's very important for life extension. All right, so we run one of the BioDAOs that Paul talked about in the first batch of BioDAOs, and basically what we do is we looked at the field of medicine, and we looked at things that are the most neglected and most underfunded, and came to the field of cryopreservation, which is very close to cryobiology, right? You have all these animals that are able to survive at very, very low temperatures. And we were quite surprised to learn that if you just lower the temperature of a human body, there's almost an immediate effect on what you can do in medicine. So you can, it's fantastic for stroke victims. It's fantastic for organ transplants. If we lowered the if we increase the time that we can preserve an organ for just 100%, so for a kidney that would be 12 hours, we can get rid of waiting lists. But we are not doing that because we just suck at preservation. We suck at sort of like logistics. And so we looked at this field and realized that we could increase the impact that we could have on these technologies by funding this very, very neglected field. And so we came together as a team, a little bit of a different team compared to the other BioDAOs. We're all like very, very focused on, we're entrepreneurs, serial entrepreneurs, raised hundreds of millions for different companies, sold companies before, and came to look at the DAO kind of ecosystem and to build an organization as a DAO because of all of these ways that we could, additional ways that we could raise money, but also engage more people. And so we, because it's a very, very small field, we really know all of the scientists in there, probably 2,000, 3,000 scientists in the entire world that are working in this field, and yet it could affect, hundreds of millions of people today. And our goal with this organization is really, really bold. So we leave those projects that can be funded by the government, so like some more basic research, and we focus on the really, really exciting stuff. So I'll give you some examples of some of the projects that we funded so far and that we're going to fund in the near future. We have a project which we just recently funded, which is called Gaia. The team, really fantastic team from Mass General and Harvard, they're taking sheep ovaries, they're vitrifying them. Vitrifying means that you put them in a glass state, so very, very low temperatures. You can keep them there essentially forever without any damage happening, because there's no, there's no metabolism happening. So they're going to take these ovaries, they're going to vitrify them, reworm them, put them back in the same sheep, and then we're going to get the sheep pregnant, which is pretty fantastic because I can tweet that we're getting sheep pregnant. Never thought that I'm going to be able to do that. We have a project which we call Lazarus, which is a full mammal cryopreservation at -2 Celsius. Never been done before in this way that we're going to do it. We have, how many of you like tardigrades? Wow, nice. I thought nobody's going to say that. hopefully, some of you are gonna really like them after this project. So it just so happens that tardigrades, you can shoot radiation at them, you can shoot them out in the vacuum of space, they survive, right? That's just crazy. You can dehydrate them to 100%, they survive. So they have these superpowers, and we work with a team that was funded by DARPA that was able to isolate the proteins that give them these superpowers. And then we're going to see if we can give these superpowers to human tissues, and hopefully, in the end, to humans. So that would be pretty fantastic. And then we have two projects that that are relevant to you right now. If you want to get involved, one project is we're working with three-letter, 3- and 4-letter organizations and 6-letter private organizations in in putting together a space biostasis prize. So you know cryosleep from the movies and stuff. It turns out we really need that. It's not just a nice trope. We really need that because space is vast, and so if you want to go to Jupiter, that's 6 years one way. If you want to go to Europa, that's 13 to 14 years there and back. Human beings are not gonna be able to do that. We're not gonna be traveling in the vastness of space, drinking our own urine in the dark, because psychologically we're just not able to do that. So what I would like to do, I would still like to travel and get to Mars and back and so on many times, but probably just take a nap. And so we're working with these organizations, and we have both scientists and engineers involved to put together an incentive prize for that, as well as a large event, bringing together cryobiologists as well as space scientists. And then we're just going to give a plug for a new organization which is called CryoDAO, which we'll be launching pretty soon. So CryoDAO is focusing on cryopreservation, and HydroDAO will be focusing on full replacement, so full body replacement. I'd love to, we haven't been doing this before, but I'd love to take some questions if anybody has questions. How do you do full body replacement? We're gonna figure it out. I guess we're gonna figure it out. So there are some. There have been some attempts and some suggestions on how to do it, but we're really at the beginning of the science around that. Yeah, absolutely.
More questions?
More questions? Cool.
I'm not sure if I understood correctly, but were you saying that we're not properly freezing organs? Why haven't we been able to do that? What's kind of the issue at the moment?
Thank you for that question. So I co-founded an organization which is called the Organ Preservation Alliance in 2014, and the why we started that organization was because we looked at some just like publicly available data about organ transplants and tissue transplants, and there's just like this black and white little piece of data there on paper which says, hey, we also throw away 90% of healthy available organs. And we're like, what? Why would we? Why don't people need those? Why are we throwing them away? And it turns out that we are really bad at preserving complex tissues. So we can preserve some tissues at very low temperatures. There's always some damage that happens when you preserve tissues. There's a reason why when you buy a nice expensive steak, you don't put it in the freezer, because ice crystals will form, and you can imagine those ice crystals growing, right? They grow, and they cut everything in front of them. So imagine that happening in an organ or complex tissues. So what scientists do is they use what are called CPAs, or cryoprotective agents, so that they protect the tissue. Different types of molecules, different types of formulations, where you perfuse the tissue with that liquid to protect it from ice formation. Some companies are using nature-inspired CPAs. Some are trying to do like just straight novel chemistry. But we are not yet there that you can preserve an organ, you can freeze an organ for more than just a few hours. So if somebody, if you need a heart, you're on the west coast of the US and the heart is available on the east coast, you're probably not getting that heart, which is crazy. It's 2024. That should not happen. But yeah.
And when do you think we'll be at a point where it is possible?
So uh, I'm going to do a plug there. So a company I co-founded just announced that we were able to do 72 hours for a kidney. And just another data bit there is that if we just are able to double the time an organ can be preserved, you get rid of all of the waiting lists, right? You essentially don't throw away 90% of valuable, good organs that we do today. So I think we're getting quite close. There are some other companies that are very, very good at it. We were able to just in the last 3 years, we were able to almost double the time that we could do liver, which is phenomenal. So the larger the organ is, the harder it is to perfuse right, and therefore also preserve right. And usually what we do is, and I've seen this, which is like really shocking. Basically how we preserve organs right now is dry ice. So they just take the organ and they just put it in ice. And you know what happens when you put any kind of food just on ice, just food, right? It doesn't taste very well because there's freezer burn. That happens to our organs today, which is terrible. So that's why we work on it.
Woo, thank you. Thank you so much, Eddie.